Hi, I'm Kevin. I'm a Google developer expert in Angular, and in today's video I will show you how you can use the Angular Materials CDK to implement component harness. But don't worry if you've never heard of component harness yet. In the description below you will find a link to a video where I explain what component harnesses are and how you can use them. But in this video we will focus on writing some component harnesses ourselves. Sounds good? Let's do this. Imagine we implemented a switch component. A switch component can be checked on click and it can be unchecked. At this point, the implementation detail of the switch component don't matter so much, because the first kind of steps to create harness are always similar. We will at some later point, when it matters, have a quick look at the implementation of the switch component. The first thing that we need to implement our harness object is the component development kit of Angular. So in our project, we can open up a terminal and type npm e @angular cdk. That's everything we need to get started. Once we install the CDK, we can start implementing our harness object. Let's have a quick look at our application structure. We have a components folder with a switch folder inside where our switch component is implemented. For demonstration purpose, everything is implemented in the same repository. So our switch component is implemented in the same repository as our app component. But in a real life scenario, this could easily be a UI component library. But the approach is exactly the same. So let's go ahead and implement our harness object. In our case, we will create a new file called switch.harness.ts. We add this file to the harness folder, but it could also be implemented next to the switch. When I implement a UI component library, I usually prefer to group all the harness objects together and ship them as a dedicated testing sub-entry. If you've never heard of sub-entries, then I recommend you to check out my blog post that you will find below in the description. This blog post shows you what sub-entries are and how you can take advantage of them to create your own testing sub-entry. But let's focus now on the implementation of our switch harness. To implement the component harness for our switch component, we start by exporting a class named AwesomeSwitchHarness that extends the component harness. As we can see, the component harness is provided by the Angular CDK, and it's the base class for all component harnesses. Whenever we implement a subclass that extends the component harness, we also have to add a static host selector attribute. During test, a component harness represents an instance of our component. The static host selector is used to match the correct component. So therefore it's important that our host selector matches the component selector of our switch component. So the switch component's component selector is named AwesomeSwitch. We can simply copy this one and use it as a static host selector. At this point, we successfully created a component harness that matches the AwesomeSwitch. So people could now use our harness to get a hold of the AwesomeSwitch. But there is no API yet. So let's go ahead and add some methods. So before we start coding, we first have to think what are possible interactions a user may have with our components, and what are possible assertions a developer might want to run. So let's take our switch as an example and think about possible user interactions. So as a user, probably the main interaction I have with the switch component is checking and unchecking it by clicking on it. In reality, there are probably even more interactions a user may have with the switch component. For example, a user might want to check or uncheck the switch component by using the spacebar. But for our video tutorial, it's currently enough if we handle the main case of the click. So let's go ahead and write the method signature for our click. Since you already watched my other video on harness testing, or maybe you were even already familiar with harness testing, you know that harness testing heavily uses the async await syntax. Therefore, it makes sense that our click method also uses the async keyword and returns a promise. So this is a possible user interaction. So let's now go ahead and think of some possible assertions a developer may run. As we already figured out, the most interaction a user probably has with our switch component is checking or unchecking it by clicking on it. So therefore it makes sense that a developer wants to check if our switch component is checked or not. So let's add an API named check that will return a promise which is of type boolean that informs the developer if our switch is checked or not. Since we are currently only focusing on the API, we will quickly return true to make TypeScript happy. Since switch is a form control, chances are high that it will be used inside a form. Whenever it's used inside a form, we also have the possibility to disable a switch based on certain criteria. So we should add a disabled method that again returns a boolean which allows the developer to check if our switch is disabled or not. Again, we will quickly return true to make TypeScript happy. So let's quickly remove those comments. Those were just helper comments that help you find a base path on how to figure out the API of a component harness. So now, how do we implement this click method? Somehow we have to access the DOM or the HTML elements of our component. So the click, for example, doesn't happen on some internal element, but it happens on the host. So somehow we need to get access to the host. By extending the component harness, we get a very handy option that delivers us the host as a test element. So we can create a host constant and we can then await this.host. And this call returns us a test element. The test element is provided by the CDK and it's a common interface which we can use for both unit tests and E2E tests. It defines a bunch of methods that represent the interaction that you have with DOM elements. For our test, the click method seems pretty interesting. So let's go back and call it on the host. Of course, this again returns a promise, so we have to await it. And that's it. That's the whole magic in implementing our click method. So by calling this click method on the test element, we are assured that the CDK takes care of change detection and fixture stabilization behind the scenes. We can even refactor this into a one-liner. So that's pretty easy, isn't it? So let's move on to the next one, to the check method. So far we haven't seen how our switch is implemented because we wanted to focus on harness testing and how to set up and write harness tests. But at this point it actually makes sense to take a quick look at the switch component's HTML implementation. So internally, the switch component uses three elements: an input, a div, and a span. The div and the span is what we actually see. The input element on the other side is visually hidden and it's only there to carry some basic information or to receive the focus state, for example. If we take a closer look at the input, we can see that the input carries a checked attribute, and this checked attribute gives us information about the checked status. On every click on the component host, in the TypeScript logic of the component, the value attribute gets toggled. And this gets then reflected back to the input as a checked attribute. So in our harness test, we somehow have to access this checked attribute. To access DOM elements inside a harness, the component harness provides us with a couple of locator functions. So we have locator for all, or locator for optional. Each of those functions accepts a CSS query to query elements inside the component. So what is the difference between those functions? Locator for will throw an error if we cannot find the specified element. Locator for all will return a list of elements, and locator for optional is pretty similar to locator for, but it doesn't throw an error if we cannot find an element. If we check the locator for function, we can see that it accepts some queries and it returns us a async factory function. The async factory function is typed using generics, and to be honest, those typing look pretty crazy. But bear with me, using those functions is actually very, very simple. So let's go back to our test. We have seen that the locator for returns a function. So it's best practice to add a private field getInput, which then is a locator for a input. So this allows us to call getInput to get a hold of the switch's input field. So as we've seen, getInput is now a function. So we can go ahead and call getInput, and it returns us a promise, so of course we have to await it. The getInput returns us a promise of a test element. So we get access to all the test elements function. We can see there are a couple of functions to interact with the element, like we can focus it, we can blur it, or we can also get some information out, for example, by calling isFocused. But there is no checked function. So how do we proceed? Well, there's a getProperty function. And this getProperty function allows us to get an element's property. So we are interested in the checked property. Since the getProperty call also returns a promise, we again have to await it. And that's it. That's everything that is needed for the checked function. So let's go ahead and implement the latest function, which is the disabled function. There are various ways to implement this function, but I want to show you a cool trick. So let's first inspect again the switch component's HTML. Our switch component is a CVA, a control value accessor, and therefore implements the control value accessor interface. So it means that the control value accessor disabled holds the state if the component is disabled or not. And then we reflect it by adding a disabled class to a span inside our slider div. Of course, we could also check the disabled attribute on the input. So the goal of this video is to provide you with as much information as possible in a short amount of time. So therefore we will use the disabled class to determine if the switch is disabled or not, because it will illustrate you another concept. So let's go back into our switch harness. We know that the disabled class is only added on the span if our component is disabled. If it's not disabled, there is no disabled class. So we can take advantage of this knowledge. So what we can do is we can use the locator for optional function. So we can say, okay, we are looking for an optional span with a disabled class. And we can call it, instead of getInput, getDisabledSpan. So this locator function will either return us a test element if it's found, means if the component is disabled, and if it's not disabled, it will just simply return us null. Inside the disabled method, we can then call this .getDisabledSpan. Of course, this returns a promise, so we have to await it again. And then we can convert it to a boolean. And that's it. So I wanted to show you this approach because it uses the locator for optional, so that you've also seen how to use the locator for optional function. Okay, great. So we implemented the API, but there is one thing missing before we can consider our harness done. Since our switch is pretty awesome, check this out. Chances are pretty high that this switch will be used all over the place. No, jokes aside. It's pretty realistic that the switch component is used multiple times inside a form or inside a component. So we already mentioned that each component harness represents an instance of our switch component. But how does he know which instance it has to be? How does he know what to target? Because we only use the host selector, and the host selector is the same for all the switches that we use across our component. So we need some sort of a filter. And that's exactly where harness predicate comes into play. So harness predicate allows us to capture components with a specific text, a class, a CSS selector, or even a custom criteria. So the official docs state that it's recommended to create a static with method that constructs and returns a harness predicate. So let's go ahead and do that. So let's add a static with method. This with method accepts some options, which are the base harness filters. And it returns a harness predicate, which is of type AwesomeSwitchHarness. For the base scenario inside the method body, we can return a new harness predicate and pass our AwesomeSwitchHarness with the options. So this allows developers to target the correct component. And how is this done? So the base harness filter provides an optional selector. And this is just a classic CSS selector. And it means that the harness will only find instances whose host element matches the given selector. There is also a ancestor attribute, which is also optional, and this will only find instances that are nested under an element with the given selector. From my experience, those CSS selectors are very powerful, and therefore it's usually enough to just use the base harness filters. But there are also cases where this is probably not enough, or you want to have a text attribute as an additional option. So in the official docs, there's a pretty nice example that illustrates how you can extend the base harness filters. So to extend the base harness filters, we first have to create our own harness filters interface. In this case, a My Menu item harness filters. You see that it extends the base harness filters, so it gets all the options that we've seen on the base harness filters, so selector and Manchester. But additionally, we also provide a text, which can either be a string or a regular expression. In the with function, we then use the My Menu item harness filters instead of the base harness filters. And we then return a new harness predicate, but additionally, we also add an option called text. We then use a callback that gets the harness and the text option that the user passed to us. In the function body, we then use a helper method from the harness predicate called string matches that then checks our menu item text with the passed text option. To get a hold of the text, we have to provide a small helper function that is pretty similar to what we've seen when implementing our click function. So we use the host and then host.text to get a hold of the text. In our case, the base harness filters are enough. So we successfully implemented component harness for our awesome switch. So let's ship that and let's imagine we switch role from the UI library author to the application developer. As an application developer, we don't want to test that a click works and that a click checks the switch component. That's something that we expect that the author of the UI component library has already tested by himself. And that's a nice thing. Harness tests can not only be used by an application developer, but also by the author of the UI component library. But as an application developer, I probably want to test the interaction between various components. So imagine the scenario where I used switch inside a form. So here I want to test the reset behavior. I want to test that the click on the reset button resets the switch component to its initial state. So in our test, we already created the whole harness setup. Furthermore, we also got a hold of the reset button, which is also a harness. So next, we want to get a hold of our switch. So we get a hold of the switch by calling the loader.getHarness, and then we pass the awesome switch harness. Since we are only using one switch on our demo page, this is enough. But remember, once we would use multiple switches, we could use the with function and then pass a selector, which is a CSS selector. For example, if we want to target the switch with ID my first switch. And behind the scenes, this would use the base harness filters. But let's remove that because in our test, we only use one switch. So next, we first want to check the switch. So therefore we call awesome_switch.click. And at this point, we expect the switch to be checked. And as mentioned previously, it's not about checking that the click works on the switch. We expect it from the library author. But if we want to be 100% sure, we can still run an assertion here. So we can call our checked method and we expect it to be true. So next we want to click on our reset button. So we will do reset button.click. And now we want to assert that our switch is not checked anymore. So if you run that, our test passes successfully. So that's it. We covered all the basics you need to write harness tests for your own UI components. If you like this video, feel free to share it and don't forget to subscribe to my YouTube channel. Till next time.